Hello SGD, Sacred Geometry Decoded. Last few days I've been putting up compilations of previous videos. This will be a new video but a compilation of many, like I'm using the same cards but it's a new video and I'll be bringing together many pieces and I'll be looking at alchemy, especially like in Western Europe, but also going back to the ancient Arabic, the Arabian alchemists such as Geber around about the 8th century, going back to Ptolemaic alchemy in Egypt, and further looking at pyramids and many other angles. But it's going to be a mix of many things, but interesting connections to consider, and we'll focus on geometry and measurement as well. So in a previous series I was looking at and putting forth the idea that based on Magley and other people's research, just extending a little bit, that the corner here where there is a door that leads to from the Khafre Valley Temple up the causeway is a 0-point marker. It's like a key point of survey on the pyramids. Now I did that in a longer series, so I won't go into that at this point, but the measurements, the angles, the solstice, equinox connections. Now, for instance, if you stand here at the 0-point marker there right at the bottom of the causeway where it meets the Khafre Valley Temple, right in between the Great Pyramid and the Caffrey Pyramid on the summer solstice, or the Egyptian New Year, which marks the beginning of a flood season, the sun rises directly in between them. That's Arket was the name of that. So again, we're relating it to alchemy, because even, for instance, the Romans made a point of celebrating the Egyptian flood season. There's a very famous temple which has 16 nymphs on there, because the average flood of the Nile was 16 cubits. But as above, so below, so alchemy. Now, here's an old symbol of a representation of Arket with the sun rising between the two mountains, and there you can see a point of it there. That's the hieroglyph for New Year's Day, which marks the beginning of a flood season. Again, you see the sun rising between the valley, and you have the palm frond on top, and the palm frond connected to Thoth and Shesset is a signature of time. So that's New Year's Day, beginning of the flood season on the solstice. And of course the flood, ever so important in ancient times, not just in Egypt, Mesopotamia, over Mississippi Valley, wherever there was a river before irrigation schemes and dams, the annual flood cycle was just the rhythm of life. And so Arket, or the flood season. The floods, there was 3 seasons in Egypt, Arket being the flood season. Here are some symbols later of Arket. So you see the Arket symbol with the sun rising between the two mountains, but they're also residing on the back of these lions, and you also have this bar on top with the 2 little bits pointed down. Now if you go, I went to Gardner's sign list and I've put these together. So you see the bar, horizon. Horizon is Arket as well. For instance, the name of the Great Pyramid was Arket Khufu, and the lions of yesterday evening and this morning being represented there. So again, the old Arket symbol, the symbol for the New Year, and these links here. Now, I'll be thinking now, for the moment, as above, so below. So horizon, or Arket, which was, again, horizon, Arket was also the name of the New Year. Now, this is another version of the Arket symbol, but what's interesting is we have the Ouroboros, the snake eating its tail, in there. This is from Cleopatra the Alchemist, with the all is one, which is very Neoplatonic, but again, this very old symbol, the Ouroboros. Again, you see it here around the young Horus. Gilded shrine of Tutankhamun, we see that symbol there, the snake eating its tail, both around the head and around the feet as well. So it's a quite old symbol. Now, there's Cleopatra the Alchemist, but on the left-hand side, here are a couple images from the famed Arab alchemists such as Geber. But you'll notice the Ouroboros eating its tail there as well. You even see the the Ankh symbol there. But notice these 2 bars, the one above and the one below. And also inside this Ouroboros we have a white, a red, and a black bird. These are alchemical symbols. This is from Splendor Solis. The white, the red, and the blackbird. White, red, and blackbird, which is Negrito, Alba, and Ruby are all the black, the white, and the red, which are very important in for the alchemists during the in Western Europe. But of course, this goes back to the Arab alchemists, and we see that interesting continued use of Egyptian symbolism. So again, the Urubus, both in ancient Egypt and also the Arab alchemists, but also these two bars. Now that's what got me interested in it, because we have Arquette. So again, these different versions of Arquette through time, the very old one up until the later periods, but still in constant use. But we see these with the lions. The lions there, the lions, and also, whose tomb is this? I forget at the moment, but we see the Mesketu, the North Star, symbol for their constellation, but next to her is a lady holding up the same emblem, that bar with the two little pointy bits down. So we see that both on those arquettes. And what does that symbol represent? Heaven, sky, ceiling, what is above? What is above? And I noticed that there, that's what got me interested. So, but this is, well, you could read that. So we see her with that same emblem. So it comes to not just hieratics, but also hieroglyphs. Most people would point to the Rosetta Stone as that where we were able to translate them. Very curious little bits such as during the time of Kircher and others that, well, were they actually at least an arcane form of hieratics, but if not hieroglyphs transmitting this? But so we have two, but now the bar with the points down is the ceiling, that is what is above. And I couldn't find it, but well, just, what is it, the way that language works, you just invert it. So as above, so what is above, what is below? As above, so below. Now, I'll link the page in some, because Geoffrey Drum has got some very interesting ideas in regards to how the pyramids connect together, and we'll look at that in a moment, because geometrically they connect together wonderfully, and he's talking about the chemistry or the alchemy related into these pyramids. Were they did they have another use? So not the not the only use. Let's be clear on that. But they also had multiple uses, and I think this is a very convenient idea, because I was only who was I watching? Space Creator Band put up one about this. So the word worship is connected to cathedrals, churches, temples, but the origin of this word comes from workship. So that the places of worship were places of workship where work was done for the gods, for the king, this type of thing as well. So, and that's not because for instance, the great cathedrals were universities. They were not just a place to go and sing your hymns and etc. They were essentially the cathedrals in a temple precinct, just like in ancient Greece as well. The temple was not just to go there and pray. They formed many practical purposes, such as storehouses of wealth. So the bank where you would go put your money would be in the temple. But with that, we'll go to the next part, and that will be looking at the famed alchemist Basil Valentine. So, which is lots of evidence would scream to the fact that Basil Valentine, was not a single person, but was a pen name used by many alchemists. But alchemists were metallurgy, dyes, glass making, cannon, of course, metallurgy, cannon making, gunpowder, and so forth. So alchemists were not just out doing airy-fairy stuff. During this time as well, they were the magistars, the scientists, the industrialists of the time. They weren't just tinkering in some hovel. They had workshops, essentially factories, pre-industrial age. People were engaged in industry, and so that will be, just need to restart. Okay, next part, so we see the Azoth of a Philosopher's Stone by the famous alchemist Basil Valentine. Again, almost certainly a name that was used by multiple people. So was there a real Basil Valentine, and then his name was replicated? Was it just to create, because Valentinus and the Gnostics, Neoplatonics back in like second, third, or fourth century Alexandria, and those 42 books of Thoth or Hermes. But what I noticed about this illustration, so this will link nicely as well. So there's one of the. This picture is a woodcut. So these illustrations connected to Basil Valentine were woodcuts based on his writings done later, not by him. But Basil Valentine, he was practicing alchemy in regards, especially the salt trade, so leading to sulfuric, hydrochloric acid, also ammonia being one of those things accredited to him. But what's going on here? Also, so this is from the secret symbols of the Rosicrucians. And so I mentioned earlier Arab alchemists such as Geber, and he's very famous. He's through time, right up until the early 1800s, around the time of Newton as well, and when this Secret Symbols of the Rosicrucians was published. Geber is famed, noted, accredited as being one of the great alchemists, and so is Basil Valentine. Now, just before that, Spagyirization or Spagyric alchemy. Spagyric with reference to alchemy in regards to medicine, but they also point to Basil Valentine. And also notice white as snow, red as blood, and we'll come to that because at the Albra, Rubia, and Negredo. But very important figure. Okay, I'll try to remember to link these, or it's just basically music going through the imagery from Azoth of Philosopher's Stone and the 12 alchemical keys of Basil Valentine. Benedictine and Hermetic philosopher. So let's look at the geometry connected now. Hermeticism, Hermes, Thoth, gods, weights and measures, science, etc. And John Dee being a famous alchemist, also famous for being the astrologer to the court. There we as a Space Creator pointed out the other day, did a video on John Dee, and one of his sigils actually matches like the Dendera zodiac, but also the Great Pyramid geometry, which is proportions of Earth and Moon in there as well. Try to remember if he's watching. He can drop the link. I'll pin that in the description, because that's another where this 311 or 1411 geometry. Yeah, just so many connections, so many. But geometry, Hermeticists, Alchemists. Albrecht Dürer, very famous for geometry, really, again, in the last upload I pointed to the fact, so for instance, the worshipful Society of Apothecaries in the city of London, famed for being a geometrician, and I think he's very clever, Albrecht Dürer, that he intentionally put in mistakes that point to something much deeper, again, this knowledge of sun, earth and moon. And I think there's a nice connection to Heliopolis in now Cairo, but also again that same geometry, the same sets of measures in regards to sun, earth and moon sides just keep reappearing. But back to Basil Valentine, and this from the Azoth of Philosopher's Stone. Now how does that connect to geometry of a pyramid? So here we have Caffrey, that's the middle pyramid at Giza. We also have the red and the bent pyramid. As above, so below, Hermes, Thoth, alchemy, geometry, all these features. Now, the emerald tablet is connected to Hermes Trismegistus, but through the Corpus Hermetica. Now, many alchemists, including Isaac Newton, famously did a translation of it. And "'Tis true without lying, certain and most true, that which is below is alike that which is above, and that which is above is like that which is below, to do the miracles of one only thing." Again, the recent uploads, last few days, it's in Deuteronomy 33. It's sort of as above, so below. also did a compilation of history of the Hermetics, sort of going into that and other features. But the point of it is, by Newton, Pyramids of Egypt, and what's these early studies of a pyramid in regards to systems of weights and measure. I covered that in expansively in the past, but just note that Great Pyramid of Giza, with its measures, probable determination of the ancient Hebrew and ancient and Egyptian cubit, original form and measures of the Ark of Noah. So these, again, in previous video, I've just gone through the history of people who our modern systems of weights and measure, including time, were all in like neck deep in this. So literally parts of the groups and societies they published on. In some cases, they explicitly said this is what we're looking at. But weights and measures in the pyramid. I think it's also nice to note that here he has a pyramid, not side on, but we see the corner angle of the pyramid. That's an important feature when people speak about pyramid angles, which have some beautiful geometry in them. They tend to think of a profile, but there's the slope angle of a pyramid, but there's also corner angles of the pyramids, because pyramids are not triangles, they're three-dimensional objects, and so thinking of them in triangles and observing in that way will only take you to the second dimension. If you think of a third dimension, there's another layer on top of that. For instance, the corner angle of a Great Pyramid is 42 degrees. Alright, Thoth, Sheshet, Hermes, 42 books, 42 guides and all that type of stuff in their weights, measures and early science. So geometry, metrology, the study of measurement, that's what Hermeticists do, that's what they did. All the famous ones were geometricians, metrologists. But back to Caffrey, red and bent pyramid now. The red and the bent pyramid both said to have been built by Snefru, but I'm not worried about that for the moment. What the point is that the red and bent are very close to one another, and they're both 200 Egyptian royal cubits high. They both have the same height. Will come towards the end. We'll come back to this because not just the Giza pyramids, but the red, the bent, Meidum pyramids and others are geometrically, metrologically linked. And of course, if you just divide something by something, you're going to get a measurement. But I'm talking about specific sets of numbers, and that's numbers related to the golden ratio, so the Fibonacci series and the Lucas numbers as well. But both these pyramids are the same height, but that's not the only thing that links them. Also, important to point out, the bent pyramid is said that they started building it, they realized, oh no, we mucked up, we're going to change the angle. And that there was an internal collapse. Well, there's been, now I forget his name, but they did some, with the most modern surveying scanning equipment, they found that the bottom section of a bent pyramid is not bowed out, but it's bowed in, which would say that this, we'll look at the geometry of it, but the bent pyramid, I believe, based on a geometry, was an intentional design, and also the story that's been going around for a long time that it was because they made an accident and they changed it. I don't think so, because why did they still come to 200 Egyptian royal cubits like the red pyramid? And that's not the only thing, because if you were to shrink down the red pyramid and drop it on top, it's the same angle. They're essentially the same pyramid on top. Now, that's the top section, but the bottom section has lovely geometry, which ultimately connects into this illustration here. But the slope angle of the red pyramid, or the top section of a bent pyramid, 42 degrees and 22 minutes, give or take a fraction. Super precise angles is very, very difficult to take, but they're very good. Like Dorner and others have measured it. It's very, very, very close, at least, or if not precisely that angle. So if we take that red section, it matches this triangle, and by that I mean I went into GeoGebra and measured that angle as well. We got 43.3 degrees. Now 43 degrees and 22 minutes is 43.36 degrees. Because of the thickness of the lines on that illustration, the warpage in the paper, the accuracy of the people drawing them, we're talking slivers of a degree margins of error. But both so the red and the bent pyramid would fit that there at the top. So we take the bent pyramid cross section, You see that top section, and there we see the red pyramid cross section. Again, because I just copy pasted it, so I could have manipulated the. I just did a quick copy paste just to illustrate it. I could have manipulated the image just to fit it perfectly, but again, you can test these things. So let's think about sacred geometry. Now, Euclidean geometry, book 1, proposition 1 is how to draw an equilateral triangle, and they use the vesica Pisces, 2 circles, same size, the center of a second circle on the edge of the first, which creates an equilateral triangle. There we see equilateral triangle, salt, sulfur and mercury, but I won't go into that for now. So there's one way to draw an equilateral triangle from the vesica, and there is another way. So from that basic geometry we can get that second element, but okay, we can go further. So that 2:3 ratio created by the vesica, we also have a 3, 4, 5 triangle, the first of the Pythagorean triplets, a squared plus b squared equals c squared. All triangles will fit that a squared plus b, all right angle triangles will fit a squared plus b squared equals c squared. But the first Pythagorean triplet, the first one where it's a whole number, 3, 4 and 5, that's the first of the Pythagorean triplets as they're called. But the vesica itself creates a 2:3 ratio, which is the ratio of Caffre's pyramid. So Caffre's pyramid is just 2, 3, 4, 5 triangles, because it's 3 wide by 2 high. Now, the red pyramid and the great pyramid, now how do they connect? Well, we take a vesica, 3 by 2. If the red pyramid set the base at there, well, the great pyramid is 3 over 2, or 2 over 3 of the height of the great pyramid is 2 over 3 of the base of the red pyramid. So we could, I didn't include that picture, but there's the Khafre Pyramid is defined by this 3:2 ratio. So Khafre Pyramid, Great Pyramid, and if we take the red pyramid, we see there's a nice connection to that geometry. Now that's not all, we'll go into it further, but back to this image and the Khafre Pyramid. Well, that's the profile, but what about, again, I mentioned earlier, the pyramids are 3-dimensional, they're not triangles, they're pyramids. They're 3-dimensional objects, so they also have a corner angle. What's the corner angle of Khafre Pyramid? 43.31 degrees, which is a nice, very, very, very close again. And what I mean is 43.31, 43.36, so 0.05 of a degree, very small amount. But so think of those links there. So we have the connections now. Also, now we're going back to the vesica, the equilateral triangle underneath. How do they link? Well, think of the bent pyramid. We draw a hexagon, again, straight from the vesica, and then we also have that a pentagram of the same edge length. And I've got some videos on how to draw Albrecht Dürer's picture for one, okay. But what happens is, from that diagram, if you fold up the hexagon or the equilateral triangle, you get the base, the lower portion of the bent pyramid. The top portion of the bent pyramid, also it's the same angle as the red pyramid, is a folded up pentagram, or pentagon to be more precise. Now I'll put that section in. So again, this sacred geometry which links these things together works very nicely to link multiple pyramids together. And now I'll put in a little section of video just to illustrate that a little bit better, because this geometry describes both the red pyramid and the bent pyramid, and the essential geometry underlying it is of the Caffrey Pyramid, which also gives you proportions between the Great Pyramid and the Red Pyramid, and there's a lot more into that. There'll be later on this section, but let's show that for now. So we begin with 4 pentagons. Now each of those red sections makes up 1/5 of a pentagon. if we take those sections and fold them up until they meet one another, what we do is we create either the red pyramid or the top section of the bent pyramid. Of course, the pentagon pentagram has multiple relations. It's actually all across the whole thing, pentagons, pentagrams, it's all about 5, the golden number, the perfect number. So by folding up these sections of pentagram / pentagon, we get the red pyramid or the top section of the bent pyramid. So the alleged mistake of the bent pyramid is actually a wonderful geometric construction, and it relates to the 6 and the 5, or the hexagon and the pentagon. So the top section, bent pyramid, series of pentagons folded up from one another. Now we have a series of hexagons which are made up of a series of 6 equilateral triangles, just like that blue triangle, salt, sulfur and mercury, that we saw with Basil Valentine's Azoth of the Philosopher's Stone. So if we take 4 equilateral triangles and fold them up together until they meet, we create many things. Firstly, we create the base angle of the bent pyramid, but we also create an octahedron. So if you were to take this blue pyramid, slice the top off, you get the base of the bent pyramid, but you also create 1/2 of an octahedron. That's based on the hexagon. And what happens if you rotate an octahedron? Star of David pattern emerges from it again. 3-dimensional gives a 2-dimensional perspective. It's like the shadow of an octahedron is the Star of David, as we see there. And of course the octahedron, one of the 5 platonic solids, creates the base angle of the bent pyramid. If the bent pyramid continued at that angle, we would create an octahedron, and each face of the bent pyramid would be an equilateral triangle. Vesica, seed of life, flower of life construction, all this geometry intricately linked. So these Hermetic themes, these themes of the Hermeticists, who are essentially, to the man and the lady, geometricians and metrologists, geometry and measurement, which relate so strongly to science, to architecture, to, well, just basically knowledge and science. This is why the gods such as Hermes, Thoth, Nuar and Phuzi, Mercury are all gods of weights, measures and astronomy and geometry and all these related themes. So this has been SGD. Thank you for watching. I'll put plenty of links in the description, and if you want to contribute to the channel, I'll put a PayPal link in there as well. Cheers and have a good one. Okay, so frontispiece and portion Azoth of Philosopher's Stone by Basil Valentine. The geometries in there, Caffrey, red pyramid, bent pyramid, also the proportions of the red pyramid base to the great pyramid height. But coming back to this elementary geometry and the 6/5. So we just saw that piece now. Okay, again, it's from an earlier series, looking at the Giza Plateau, and especially the Khafre Valley Temple as a 0-point survey marker. And why that? Well, so in that dark blue line, that's the causeway. That's 14 degrees above true east-west. 14 degrees above that is the center point between the Khufu and the Great Pyramid and Caffrey, which is the summer solstice, the beginning of the flood season. Now, so what I just did was, okay, let's look further. So I extended that down another 14 degrees. And again, they all meet here at this 0 point at Khafre Valley Temple. Passes over, for instance, passes over the back of a sphinx, touches, what's that one as well? Okay, but, so another 14 degrees below, it hits Menkaure Pyramid. And another 14 degrees below that would point to the winter solstice. And that touches precisely the corner of Kent Kauwe's pyramid. Now, if you extend the line of Kent Kauwe's, points directly to them anyway, but there's like, yeah, it's so much going on in there. But so this is the concept of it, and that's an astronomical marker, which would be important. But there's measurement in here as well. Now, even the degrees and the numbers. But so from this 0-point marker, summer solstice, that when the solstice finishes, it's 180 days to the winter solstice. From that point, the line would touch the corner of Kent-Kaway's tomb or Kent-Kaway's pyramid, 180 days or 56 degrees. However, there are 3 seasons in Egypt, each of 120 days. So from summer solstice, so the season of Arket, the flood season, is 120 days. That's 36.87 degrees, give or take a fraction. Now back to the geometry of Caffrey Pyramid. That being made of 2, 3, 4, 5 triangles. Well, what's the angle of a 3, 4, 5 triangle? 36.869, just let's call it 36.87 degrees, which fits very nicely in with there. So this will be also, pyramids are connected. Also important to note, because we're talking about not just slope angles but corner angles, and from this point you see the corner angle of a pyramid, not the slope angle. But I won't go into that for now. So this was so we started Giza. Well, let's go down to Thebes. Okay, so where the Valley of the Kings is as well, and again the importance of those astronomical markers for solstice, equinox, and the marking of a flood season. So there's a famous Colossi of Memnon. You can see here before the High Aswan Dam how different the landscape was during the annual flood cycle. So the map now, and it would look something more like that. So you had Luxor Temple and Karnak Temple. They had big mud brick walls around there, so they would have stayed high and dry. Same with other temples here in Thebes. Again, Arket, the flood season. Now, it's the heartbeat of Egypt. So again, early video, so I won't go through more. But we have like all of these temples here are all aligned at 28 degrees to the summer solstice sunset or the winter solstice sunrise. But amongst them as well, for instance, Luxor, Medinet Habu, and Deir el Medina, they also have these alignments in them of 36.87 degrees. So the 345 triangle or the Khafre Valley, sorry, the Khafre Pyramid angle as well. Also the 42 degree angle of, so the corner angle of a pyramid is 42 degrees. So these angles are just popping up, but also the super important solstice angle alignments. Temple of Seti I and the famous Osiron. That's well, what's the angle of there? It's 53.13 or 36.87 degrees from true north. Again, Khafre Pyramid angle, 345 triangle, or the 2:3 ratio of a vesica. Again, Arket summer solstice, but Abydos and Thebes, we see the same thing going on. So again, the Khafre Valley, Khafre Pyramid, 3 wide by 2 high. It's the vesica, 2, 3, 4, 5 triangles. The angle of that 120 days being nicely fitting in as well. Inside the Great Pyramid, the King's Chamber creates a 3, 4, 5 triangle from going across. And so that again creates that same set of angles. But how important is the Khafre Pyramid? I would say it's very important that it forms a template for not just linking the sizes of the Great Pyramid to the Red Pyramid, but other pyramids as well. So the 3, 4, 5, up here we have Giza Plateau. There's a Khafre Pyramid and the 3, 4, 5 triangle. But what about all these other pyramids down to the south here? Okay, so Pepi II, 3 wide by 2 high, or 2, 3, 4, 5 triangles at that same angle. And it's 150 Egyptian royal cubits wide, 100 Egyptian royal cubits high. We can work that out even though they're in really poor state because of the slope angle of the surviving casing stones. Merenre, same thing, 150 wide by 200 high, again because of the surviving casing stones and the footprint. We can work that out. So it's not just the same 2:3 ratio of the Khafre Pyramid, it's also showing a standardized set dimensions, 150 wide by 100 Egyptian royal cubits high. This is an important feature as well. Pepi I has the same thing. Teti, same thing. Usakaf, same proportions, same dimensions as well. When we come down to Menikamal, That is really bad state, but it's 100 Egyptian royal cubits wide, or very close to it, and it's also some suggestion that it's the same 3 wide by 2 high. That's a difficult one, but still 100 Egyptian royal cubits wide. Now that's important because of stretching the cord ceremony, but whether it's Abydos, all over Thebes, again all over Egypt, we see these same solstice alignments, but also the same proportions and angles of the Great Pyramid and Caffrey Pyramid. But the key here is that these are 150 wide by 100 high. Something of a standardized size. Now, 100 Egyptian royal cubits relates to Sheshet and the stretching the cord ceremony. Very ancient, right up until the last days of Egypt, where Sheshet would help the pharaoh align her temple and set the proportions of them using the Sketyu or the North Star. But they also says we use the measuring cord. Now the measuring cord is 100 Egyptian royal cubits. And so those proportions now, so keep in mind 100 Egyptian royal cubits. Back to the plateau there and the various alignments. Now, it's this green line from the 0 point to where it touches Menkaure is the perimeter of Khufu, or the Great Pyramid, which relates to the size of the Earth in regards to when you divide it up into degrees and minutes. But what's important is the blue line, the Caffrey Causeway, and from the 0 point to where it touches Kent Cowways, which is on the summer solstice. That is, again, I measured it, pi 100 meters, which converts to 600 Egyptian royal cubits. Again, the importance of the cord, 100 Egyptian royal cubits. Now, all those other pyramids I showed, which had the base of 150, their perimeter, therefore, is 600 Egyptian royal cubits. So, for the perimeter of all these other pyramids, which are based on the geometry of Caffrey Pyramid, we have that there. The green line is the perimeter of the Great Pyramid, and the blue line is exactly double that, so it's 1200 Egyptian royal cubits. You can also see the angles, it's 208, so 14 degrees above true east-west. So the geometry, so whether it's smaller or larger, they're still using the same 2:3 ratio, that angle being so important again in Abydos and in Thebes. And time, measuring length, geometry, all based in the same thing. Okay, so yeah, but no, but. Well, now let's look. So we began with that as above, so below symbolism. Then we went into the Azoth of the Philosopher's Stone and those triangles being linking Great Pyramid, Caffrey Pyramid, Caffrey, Great, and the Red Pyramid, and also the Bent Pyramid. So we've also set up something of a connection between those. Also, all those other pyramids to the south at around Abu Sir, etc. They're linking up nicely as well. But there's more to it than that. There's more. These geometry and these measurements link up really nice, and at very important ratios. Very, very important. Again, linked all beginning from the Vesica. Okay, so let's look a little bit further in regards to how these geometries are connected, proportions, also measurements and geometries. But we have the 3 Giza pyramids, Menkaure, Caffrey, or Khufu, or Great Pyramid. The Red Pyramid, we also had this pyramidion found next to there, next to the Red Pyramid, Bent, and Maidum. So we begin with the 7:11 ratio. That's think Lucas numbers. So we have the Fibonacci series 1, 1, 2, 3, 5, 8, etc. The next related to that is the Lucas numbers, which so Fibonacci begins 1, 1, 2, 3, 5. The Lucas numbers begin 1, 3, 4, 7, and 11. So Great Pyramid 440 by 280 cubits. You can reduce that to a 11 wide by 7 high ratio. Now the Maidum Pyramid 275 by 175, that has the same proportions. Now that's the casing stones, again that collapsed, but there are surviving casing stones. We get the angles from there. But also the Pyramidion that was found next to the Red Pyramid, 3 Egyptian royal cubits high, which makes it 1 meter high. That gives it the same 7:11 proportion. So we see some links there. Now those are the Lucas numbers. So in that same Lucas geometry we also get the 4/7, 4 and 7 being Lucas numbers. Now you think about cubits. Cubits are divided into 7 palms. And so the forearm is 7 palms, and then the hand is 3 palms long. So 1 cubit, 7 palms. The forearm is 4, and the hand is 3. Now it's very interesting in regards to pendulums that, so like with Da Vinci's Vitruvian Man, again based on ancient Vitruvius writings, the foot is also the forearm. Okay, but 4 palms is a foot, or 16 fingers. The precise difference between an Egyptian forearm and the more modern forearm is precisely the number of millimeters that separates a 1 meter pendulum from the Mersenne-Riccioli pendulum. But anyway, we have these same divisions being an important feature. So from this spiral, this is a Lucas spiral, not a Fibonacci spiral, but when you reduce it again, so 3 and 4 are the next down. 3 and 4. Now that gives us Caffrey's pyramid, which is a 3, 4, 5 triangle to get the slope angle. A squared plus b squared equals c squared. Again, it's mentioned earlier also in the King's Chamber. And you also look to Kepler, who talked about the golden ratio, but also the importance of 3, 4, 5 triangles. We'll go into Kepler's laws for now. But that 3 to 4 ratio is also linked in Fibonacci numbers, because again, the same. Talking about geometries, now we have the Fibonacci numbers. So in this, we also have the 2 to 1. So the floor is of the King's Chamber and the Great Pyramid is 20/10. That's a 2 to 1. There's musical proportions in there as well. 3 to 4 is musical. 2 to 3 is musical. But there we also have, from the Fibonacci numbers 2 and 3, we also get the vesica, which fits the Khafre Pyramid. So again, a nice set of links. And so the Red Pyramid, if you were to take the Red Pyramid and drop it on top of a bent pyramid, it's the same height. So bent pyramid 200 Egyptian royal cubits high, Red Pyramid 200 Egyptian royal cubits high. The slope, or the angles of the Red Pyramid, are the same as the top section of the bent pyramid, but they're both 200 Egyptian royal cubits high, which is the base length of the Menkaure Pyramid, running east to west. The north to south is a touch shorter, but the 200 Egyptian royal cubits, Menkaure. So again, if you were just to take the bent pyramid and extend the lines out, you would have the Red Pyramid. The base is 420 on the Red Pyramid. The height of a Great Pyramid is 280. Again, that's that 3 to 2 ratio from the vesica, which is the Khafre Pyramid, of course, as well. So we see how these link. Alright, so Lucas numbers and the Fibonacci numbers, and especially using the spiral, you can see the proportions are always going to bring you to the, the further you go, the closer and closer you get to the golden ratio. That's Lucas and Fibonacci. And I'll try to remember that link as well, where I talk about the Fibonacci, Lucas numbers, and the pyramid proportions, and how they link to, well, natural geometry. The number of petals on flowers, the angle at which things grow, that golden angle, and of course back to the pentagram. Also, like again in the Vitruvian Man, where the omphalos, or the navel, if from the belly button to the top of your head, if that's 1, then you have a phi ratio from there. But which of course pentagrams, pentagons, and of course that geometry of the red and bent pyramid, but also built into the Great Pyramid because of that 7/11 angle all over the joint. But yeah, golden ratio, these very simple geometries leading to so much. Okay, I already showed that one. If you just YouTube King's Chamber model, how to make one, how to. I've got some videos on how you can get it from the vesica using a piece of paper, some sticky tape. You can make models of that. Fibonacci numbers, vesica. Okay. Of course, those triangles. Again, that's that same job. Now we come back to the bent pyramid. So if you were to use the bottom section and extend it up, each face would be an equilateral triangle. So again, from that vesica geometry in the Khafre Pyramid, which gives a proportion of the Great Pyramid to the Red Pyramid. Also, yeah. So again, that's just a hexagon folded up. You get the bottom geometry of the bent pyramid. If you take a pentagon and fold it up, you get the top geometry of the bent pyramid, which is also the same as the Red Pyramid. 6s and 5s, Microcosm and Macrocosm. Now, the Subterranean Chamber, if you take the height of a pyramid from the top to the ground level, if that's 5, and if you include the Subterranean Chamber, that's a 5:6 ratio as well. That sort of Microcosm and Macrocosm of the Alchemists. So Fibonacci numbers as you extend it out, so 1, 1, 2, 3, 5, and then 8. 5 and 8. Menkaure Pyramid, 125 high and 200 wide. 200 wide by 125 high, or a 5:8 ratio. The width of Menkaure Pyramid is the same as the height as the Red and the Bent Pyramid, which means the height of Menkaure's pyramid is at a 5:8 ratio of the Red and Bent Pyramid, but the Meidum Pyramid and the Great Pyramid have the same geometry. However, what proportion are they at? It's at 5:8, so 440 Great Pyramid cubits base divided by 8 times 5 gives you 275, and the same thing happens with the height. So these are very simple geometries, so important throughout these ancient architects, right up until modern ones such as Ian Pei and Norman Foster, Daniel Libeskind. They have, well, these connections, and I think that's, yeah, back to the beginning, as above, so below, that archet, these particular symbols and how they relate to alchemical symbols throughout the time. Again, in the Chesed series and the other pyramid series I've done, I'm talking about like the North Star and the stretching the cord ceremony, how that's so important. The cord, of course, relating. Even I won't go into that. As above, so below. And so again, so you have the heaven or the sky, what is above, the horizon, and then the lion gods of yesterday, evening, and this morning. So I mentioned the alignments to the solstice. Well, if you look at the sunset, you'll get winter and summer solstice in the evening. But if you turn the other direction, you'll get the reverse. The summer solstice and winter solstice are sunrise. And of course, that alchemy connections, and I'll put Azoth Philosopher's Stone, or how these have just gone through history, the geometry of all these really famous Hermeticists, and like Newton, he's just there. So it's, it is a stretch. It's very, like there's no smoking gun to say these things link. But given, for instance, a 2:3 ratio, the perfect fifth in music, the perfect fourth being the 4:3 ratio, which is a 3-4-5 triangle. Yeah, so it's a sort of one or two are a coincidence, but that there are traces throughout time, sort of linking these. So it is tenuous, but to say that there's nothing there at all is, well, a bit of that's a bit tenuous too, I would say. but it's what these things are. So they're measurable, they're tangible, testable, because of the flood season and the seasons being like that's literally written down. That's not contentious at all. And it just so happened, what's questionable, or is did they have the 360-degree compass? No direct record that the Egyptians had it, but it was being used at the same time in Mesopotamia, where they were dividing up into 60s. So 360 degrees divided into 60 minutes divided into 60 seconds. This does go back to very ancient times, and they're literally their neighbours. They were just off to the side. So whether they were using it widespread, whether it was just amongst the mystery schools, like again, 3, 4, 5 triangles was Pythagoras. Essentially, like before the Greeks, no one knew about pi, no one knew about the golden ratio. No one knew about the Pythagorean theorem. Well, Pythagoras, Eudoxus, Thales, in the old writings, they literally said that they learnt them from the Mesopotamians and from the Egyptians. But yeah, it's just the connections, the measurements, the same proportions, the same measurements. Those measurements, like coming back to the Giza Plateau itself, and connected to these, the layout, to the solstice alignments, and as I already mentioned, so the blue line and the green, the two blue lines are the same. They're just twice as large as the other, but connected to the Egyptian chord, or pi 100 meters, and also the green line being the perimeter of Khufu's pyramid, which is 1/43,200 of the equatorial circumference of the Earth. Yeah, it's sort of measure, and so the 711 is, even by the known Egyptian mathematics and the way that they created their angles, that's there certainly, but it's really simple geometry. It's just a couple circles and just extending the line out to get the Lucas spirals and the Fibonacci numbers as well. And the they are literally there in not just one pyramid, but also those same proportions link all of these pyramids. And now, if it is a coincidence, it's a bloody beautiful set of coincidences. So even if you say, well, it's just accidental and there's nothing really there, at the very least, it's a fantastic learning system to memorize. Because this is not just a pyramid. You can use this same geometry to learn so much about math, geometry, astronomy, music theory, arithmetic. The quadriviums, all in there. So if it is coincidence, at the very least, it's just an awesome set of coincidences that you can use as a great learning tool. And if kids were to learn this stuff in a more exciting way, as was Rudyard Kipling, if history was remembered as stories that would never be forgotten, paraphrasing that slightly, but the same thing with this type of knowledge. If it was taught in a more exciting, coherent way, I think it would be much, much better. And personally, I believe that it was being used in the past, but at the very least, it is there, can be measured, can be tested.